we're asked to determine the area under the standard normal curve. So this is a rough drawing of the standard normal curve. I am not an artist. It's not a good drawing. Sorry. But that lies to the right of the z-score of negative 0.97. So in z-score land, when you convert things to a z-score of 0 is where the mean is at the center. So a z-score of negative 0.97 is a little bit to the right. And then a z-score of negative 0.59, somewhere between the negative 0.97 and the 0, right? So let's see what they're asking for. They want us to determine the area that lies to the right of negative 0.97 and to the left of negative 0.59. So this is the direction to the left of negative 0.59, but then we're going to stop here. This is the area to the right of negative 0.97. That's where those two areas meet. Left of negative 0.59 and right of negative 0.97. It's the area in between those two. So to find that, what the z-score table does for you is the z-score table tells you the area to the left of a certain z-score value. So the z-score table is about to tell us better. You guys should give me a rating on my drawings in every video. So if we look up negative 0.59, the z-score in the z-score table, it's going to tell us all the left tail area, not just the area in between these two numbers. Okay, so let's do that. Negative 0.5 is here, and then negative 0.59. Here's the the 0.9 part in the hundredths place. So negative 0.59 links up at this number right here. It's kind of like playing Battleship. There's the first decimal, negative 0.5, and then there's the second decimal, negative 0.59. So 0.2776. That's the area to the left. Now it's got some extra stuff. We don't want this extra tail, so we got to go back to the table and we got to look up the next number. We got to look up the z-score, the other one we're given, negative 0.97. And again, it's going to give us all the area to the left. So here's negative 0.9. Here's the 07 part, the 7 in the hundreds place. So negative 0.97 link up at 0.166. 0.166. So if I was to superimpose this on this graph, that's this area. Look, if you subtract these two areas, if you subtract 0.2776 by the blue area, that's going to give us the area in between. 0.2776 subtracted by 0.166, 0.1116. That's the area in between those two. Okay? Because if you take out this blue area from all the orange area, what you have is the area in between. So 0.1116. I think that's all we need to do for this one. Let me see if I can find another one. Well, I'll make another video for empirical rule. Binomial, we'll use that. We'll do that in just a second. I'll show you what you got to do there and stuff. No. Come on. This is a similar one. That one we did is probably as hard as they'll come for this topic, that last one. This one's going to be a little bit easier. Okay, we're supposed to determine the area under the standard normal curve that lies to the right of z equals 1.73. So here's z equals 0, here's 1.73. So the area to the right should be kind of small. Okay, and then something I didn't emphasize in that last video, you know, the area under the entire normal distribution equals 1 because it adds up to 100%. It's all the possible options. Okay, so to find the area to the right of 1.73, we have to keep in mind that the table only is going to give us the values to the left. So when we look up 1.73 in the table, it's only going to give us the values to the left over here. So here's 1.7. Oops. Can't highlight. There's 1.7. And here's 0.03. So they link up right here at 0.9582. That's the area to the left. But we want the area to the right. So using that fact that the whole distribution adds up to 1, we just need to take 0.9582 and subtract it from 1. That's the area to the right. So if they ask you for the area to the right, 0.0418, you just need to subtract whatever you get from the table from 1. Let's check our answer just to make sure I didn't get anything wrong. There we go.